Lesson 9 from chapter 1. So, this is chapter 1, lesson 9, and the title of this lesson is Direct Variation. Okay, we go back to our essential question, being the last lesson for this particular chapter. So, how can you show that two objects are proportional? All throughout the lesson, we've been talking about rates, unit rates, we've been talking about uh, proportional, non-proportional relationships. And we've also discussed constant rate of change, and even slope. So this particular lesson actually uh, combines all of them. And this lesson is titled Direct Variation. Okay, so before we even go to the lesson, let's take a look at the two words. Okay, two terms that we need to define: direct variation and constant of proportionality. So let's take a look at direct variation. I took the liberty of writing down those two definitions. Direct variation is when two variable quantities have a constant ratio, okay? And constant of proportionality, okay, it is the constant ratio or the constant of the variation. Okay? So one thing that you need to understand is when you see the word variation, variation means to vary. Okay? Or change. Okay? So when you talk about variation, it talks about change. Okay? And we've been discussing different ways of change in the previous lessons: change in y over change in x. Slope is actually the rise over run, which is also the change in y over change in x. So in this lesson, we are going to dwell more on how all these terms relate to one another. Okay? So let's take a look at the real world link and see how this works in the real world. Sorry, the screen keeps moving. This distance y a car travels after x hours can be represented by the equation y equals 65x. The table in the graph also represent this situation. Now, before we analyze this particular problem, okay, let's take a look at the equation y equals 65x. Okay? So you have y right here and x. And y and x here refers to our graph right here. Okay? And in our graph, you can see, okay, that on the x-axis is time, and on the y-axis is distance. So this is your y-axis, x-axis is time, and y-axis is distance. So I can actually write this as xy right there. Okay? So on the x-axis will be the time it takes, okay, and the distance it will be in miles. Time in hours, okay, distance in miles. So if we look at the table first and look at here. So in 2 hours, the distance traveled by the car is 130 miles. So this is in 2 hours. The distance traveled by the car is 130 miles. So this is what it means right there. Okay. In 3 hours, the distance traveled by the car is 195. According to our graph right here, we plotted. Okay, 3 hours, 195 is approximately here. And in 4 hours, the distance traveled by the car is 260 miles. So 260 is around this area right here. Okay, so our table has been converted into 3 ordered pairs: 2 130, 3 195, and 4 and 260. Okay, So fill the blanks to find the constant ratio. Okay. Uh, Constant ratio simply means that you have the same ratio, meaning constant. Remember, the word constant means same. Okay, so distance traveled, we'll look at the first ordered pair, 2 and 130. Distance traveled, 130 over 2. Now if you notice, distance traveled is y, and driving time is x. So you actually have y over x right here. Okay, remember the change in y and change in x. Okay, this is basically almost the same. So you have 130 over 2. Okay, 195 over 3. Okay, from here. And 260 over 4. So those are all the three ordered pairs we got from our graph and from our table. So if we look at our constant ratio, okay, and if you notice here, it says miles per hour. And when you see miles per hour, we're basically looking at your unit rate. So if all of these ratios are the same, okay, that means I can find the unit rate. And the unit rate would be 65. Because if I divide this one by 2, and I divide this one by 2, I'm taking it from 130 over 2. I get 65 over 1. So the constant ratio is 65 miles per hour, or the unit rate is 65 miles per hour. The constant rate of change or slope, okay, remember, will be in change in miles, which is also our change in y, over change in time, which is also our change in x. Okay, and if we use the formula for slope, okay, wherein this is y2 minus y1 over x2 minus x1 right here, okay, we still get the same, which is 65 miles per hour. So what is given here is the constant rate of change, or the slope, and what is also given here is the ratio. So how do we now answer number 3? Write a sentence that compares the constant rate of change and the constant ratio. Basically, they're the same. They are the same. So the constant rate of change and the constant rate of change, correct, and the constant ratio are basically one and the same thing. Okay? Let's take a look at the key concept for this lesson, direct variation. And let's read through the definition in words. It is a linear relationship. Okay, a linear relationship is a direct variation when the ratio of y to x is constant k. We say that y varies directly with x. So again, according to this definition, it now includes one other variable. It is a constant k. So with direct variation, okay, if you look at it in symbols, this is how it's going to look like. Direct variation is y over k, y over x is equal to k, or y equals kx. When you see this equation, okay, right here, it simply means that y varies directly with x. What does that mean, varies directly with x? It's just basically another way of saying that y changes directly as x changes. Okay? So that is your direct variation equation. A good example, let's say, for direct variation where they vary directly with each other is that uh, your grades vary directly with the amount of time you spend studying. What does that mean? It simply means that as you increase the number of hours you amount studying, your grades will also increase. So that is a direct relationship, or they vary directly with each other. That's what it's saying. Okay, so as a model, this is how a direct variation would look like. Okay, it's going to be a graph. Okay, and if you notice, it is a linear relationship. That means it forms a straight line. Okay, and this is your direct variation equation where y varies directly with x. Okay, and uh, k is your, this is your k right here, which is 2. So that is your k. So it follows this equation right here, y equals kx. Okay, again, where y varies directly with x. And if you notice, it's a linear equation. Okay, there's the x-axis, there's the y-axis. Okay, and that's your example, y equals kx. And if you notice, it goes through the origin. And if it goes through the origin, remember what that means. Okay, it is a proportional relationship. Okay, and if it's a proportional relationship, therefore it also has a uh, constant variation. Okay, it has a constant rate of change, I mean, because the constant variation we haven't learned yet. So it will have a constant rate of change, okay, which we know for a fact that it will have a constant rate of change, okay, which is the same as your unit rate, which is the same as your slope. And we will add more to these definitions because in the bottom, when two variable quantities have a constant ratio, okay, just like what we learned uh, in the real world example, the relationship is called a direct variation. So if they have a constant ratio, it is called a direct variation. The constant ratio is called the constant of the variation. The constant of the variation is also called the constant of proportionality. So we can add terms to our constant rate of change, unit rate, slope. So this is now constant, okay, of variation. And we can also add another term, constant of proportionality. And remember, these are one of the words that we described before we began the lesson. So if you notice all these terms, okay, oops, I'm not going to erase it. All these terms mean one thing, okay? So your constant rate of change is the same as your unit rate, it's the same as your slope. It is also the same as your constant of variation or the constant of proportionality, okay? So everything is now, okay, being combined, all the lessons, okay, being combined. You have a straight line, you have a constant rate of change. We know that the straight line that goes to the origin is a proportional relationship, okay? And also, okay, we need to understand that in a direct variation equation, the constant rate of change or slope is assigned as a special variable k, okay? So your k here, which we defined, is also your slope because it is your constant of proportionality, it is a constant of variation, so your k is also your slope. Okay, remember that. Okay, let's take a look at example number 1 and see how this works. The height of water as a pool is being filled is shown at the graph. Determine the rate in inches per minute. Let's analyze the graph. On the x-axis, again, we have time, which is in minutes. On the y-axis, we have your height, which is in inches. Okay, and let's read through the problem. The height of the water as a pool is being filled is shown in the graph. Determine the rate of inches per minute. Notice inches per minute right here is already asking for your unit rate. So if that is your unit rate, you're also being asked for your K, which is your constant of proportionality, or your slope. So all of these things are the same. Okay, so again, let's take a look at the graph. So in 5 minutes right here, okay, the height of the water in inches is 2. Okay, in 10 minutes, you have 4 inches of water. In 15 minutes, you have 6 inches of water. And in 20 minutes, you have 8 inches of water. And those are all represented by your ordered pairs. Okay? Okay, so since the graph of the data forms a line, the rate of change is constant. So here is your straight line. The rate of change is constant. And we know it's proportional because it goes through the origin. Okay? Use the graph to find the constant of proportionality. So all we need to do is use the graph to find our constant of proportionality. And let's take a look at this one right here. So again, this is our y over x, height over time, y over x. Remember that. Remember when we talk about direct variation, it's y over x equals k. Okay, so remember that equation. Okay, so after we find y over x, we also find the value of k, which is our slope, our unit rate, and our constant of proportionality. So let's continue. So you have your height over time, which is y over x. Let's take a look at the first ordered pair. Again, your y is 2, your x is 5, so it's 2 over 5. If I make that into a decimal, you can use your calculator for this. We can do 2 divided by 5, which is 0.4, okay, over 1. Getting the unit rate, so we divide this by 5. We also divide that by 5, which will give you that unit rate, okay? So the next thing we need to do is take a look at the next ordered pair, which is 10, 4. Again, it becomes 4 over 10 because it's y over x. We know it's also 0.4 over 1. We have the ordered pair 15, 6. Y over x becomes 6 over 15. Again, 0.4 over 1. And lastly, 8 over 10, okay, which is our ordered pair 20 and 8. So with that, we are able to determine that since we have a constant ratio, okay, since we have a constant ratio, we actually found our unit rate as well. So after finding our unit rate, we know that the pool actually fills at the rate of 0.4 of an inch per minute. And if you notice, all the terms that we've been learning in this chapter are now being combined with each other. Okay? Do the guided problem, and let's see if you understand example number 1. Okay, so let's take a look at example number 2. The equation y equals 10x represents the amount of money y Julio earns for X hours of work. Identify the constant of the proportionality. Explain what it represents in this situation. So again, when you talk about the money, okay, the amount of money Y Julio earns for X hours. So basically saying, since we know that Y, okay, Y varies directly with X, We can also say that in this case, the amount of money, which is also y, okay, varies directly with the hours worked. Okay. So when you talk about direct variation, y varies directly with x. In this case, the y is amount of money and x is the hours of work. So we can also say that the amount of money varies directly with the hours worked. Okay, worked. Okay. So explain what each situation represents. Before we even go there, okay, let's take a look at y equals kx. Okay, so y equals kx. If I write down y equals kx, this is what it represents that y varies directly with x, where k is your constant of proportionality. So this is your constant of proportionality. Okay, and you have if you have y equals 10x, this will be your k, 10. Okay, so let's do this. Y equals kx. Okay, and if you notice, your constant of proportionality is equal to 10. What does 10 represent? Remember, 10 is a constant of proportionality. It is also your unit rate. Okay, so this is also your unit rate. Okay, this is also your slope. As unit rate, what does it represent? It represents that uh, the constant of proportionality is 10. Okay, that's what we know. So what it's saying is that Julio earns 10 hours, $10 for every hour that he works. So this is your constant of proportionality, which means 10, okay, dollars for every 1 hour worked. Okay? Okay, do the guided problem and see if you understand this example. So let's determine direct variation. Not all situations with a constant rate of change are proportional relationships. Okay. Likewise, not all linear functions are direct variations. So we are going to look at different situations where you don't have a direct variation or a constant rate of change. So example number 3, pizzas cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? So the first thing we need to do is you need to create a table for this where the number of pizzas, okay, is your x and y will be the cost. Okay, so what it's saying is that for pizzas cost $8 each and $3 delivery charge. So let's say if you order one pizza, it's going to be $11 because this is going to be $8 plus $3 delivery charge. If you order two pizzas, okay, it's going to be $19 because it's going to be 8 plus 8 plus 3. Okay, same thing if you order three pizzas, it's going to be 8 plus 8 plus 8 plus 3. That's why it becomes 27. And finally, the same principle is applied. It's going to be 8 plus 8 plus 8 plus 8 plus $3 delivery will give you $35. So now that we have created our table, okay, and we know that the number of pizzas uh, is your independent variable, y is your dependent variable, therefore y varies directly with x. Okay, that's what it means. Okay, y, uh, we can also say that the cost varies directly with the number of pizzas, or uh, the cost changes directly as uh, the number of pizzas. So we can make this ordered pairs, x and y. So if x is the number of pizzas, this will be 111, this will be 219, this will be 327, and this will be 435. So after creating our ordered pairs for our number of pizzas, we now graph our values, ordered pairs. Okay, 111, 219. Okay, so when we graph these values, okay, this is what we're going to have. So this is now your 111. Okay, right here, 111. Your 219 is here, 219. 327 is here, okay, and 435 is right there. Okay, so after we graph them, we can see right away that it is a straight line. Okay, but what do we notice about that straight line? It does not go through the origin. So therefore, if it doesn't go through the origin, we know right away that they are not proportional to each other. So if it's not proportional to each other, okay, it is therefore not considered to be a direct variation. Okay? Okay, another way of looking at this is to see if we have a constant ratio. So again, x is the number of pizzas, y is the cost. So that's exactly what we're going to have here. Okay? So you have cost, which is your y over x. So this becomes your y over x. Okay? Number of pizzas, 11 over 1. 19 over 25, or 9.5. If you notice, we don't have a constant ratio because this is 19.5, this is 9, this is 8.75. There is no constant ratio. Therefore, and the line does not go through the origin, so there is no direct variation. Okay, remember what direct variation is. It has to be a straight line that goes to the origin. Okay, they have to be proportional for it to have a direct variation. Okay, do the guided problem and see if you understand this example. So the final example is example number 4. In example number 4, it's asking uh, determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. So we want to make sure, okay, if it's a direct relationship and if it's uh, and we need to state the constant of proportionality. So we don't even have to guess what is x, what is y, because it's given here. X is your time, y is your wages. Again, we look at x over y, okay, will be equal to k. That is our direct variation equation, okay. So if we do that, okay, first we need to compare the ratios to check for a common ratio. So since it's, sorry, I inverted it's y over x, I'm sorry, y over x. That's why. Okay, so if we do our ratios, okay, our y will be our wages because that's our y, and time will be our x. So if we do our ratios, we have 12 over 1, okay, which is this one right here. Okay, the next one will be 24 over 2, or the same thing as 12 over 1. Okay, so this one. The next one will be 36 over 3, okay, or the same thing as 12 over 1. And the last one will be 48, okay, 48 over 4, which is the same thing as 12 over 1. So if you notice that we have a constant ratio, so the ratios are the same, okay. If the ratios are the same, the relationship is a direct variation, okay. So the constant of proportionality here will be our k, and we know that y over x is 12 over 1, okay, right there. So that will be our k, and that's the reason why it says constant proportionality is 12 over 1, okay. And that's the end of our lesson. Thank you for watching.